My part will be lightweight, and I will go slowly. I was told that I should have enough time. For network people, I think very rarely we actually think about security as the very first thing when you start doing something, some design. I'm not going to name names, but just as an example, one of the talks, we were at the NIST for the NDN community meeting. And some talks after the finished, the other people come along and say, "Where's your security?" And that's shocking. I don't know who is shocked. Maybe whoever asked the question is shocked to say, how come this presentation didn't have security? Or maybe the presenter gets shocked. How could you ask me this question? So in NDN, security is actually ingredient in designing. But this is a part I believe much less known or appreciated by the community. Outside the ICN community, if you mention about information-centric networking, I would believe that more often than not, the other parties would consider ICN is a very fancy way to do content distribution. To me, I'm not saying content distribution is not important. This will be just part of the future networking. Just like the dynamic routing is a part of the internet, and in-network storage will just be part of it. It's no longer a special thing. One has to pay special attention or do special things about it. But the security, on the other hand, is really the new thing that people haven't thought should be built into network. Just like I said, the system should have storage, it should provide content services. The security should be part of the network. This concept has not been populated widely. So that's why we're doing this tutorial and hoping to bring up both the attention to this importance, but also show you that what tools, concepts, the 8 years of NDN project team has developed, and in your work, you can make use of that. Now, I just gave some higher level comment to say that security, everyone understands how important it is. The thing is really how much progress we have made. This is not due to lack of efforts. I remembered in 2016 when NIST hosted the first NDN workshop. The Dr. Ken Calvert, at that time, he just stepped in as the director for NSF CNS, Computer Network Systems. And he mentioned that the security branch, SET, actually had the largest budget, larger by big amount compared to all the other areas. And so there were lots of people actually working hard. The fundamental question is, where is that fundamental breakthrough in security, in securing the system? If we tried so hard and haven't had this breakthrough, and what's the problem, right? Is that we are not smart enough? Should we question ourselves? Oh, there's something else. Somehow the slide didn't go right because I wanted to quote the something that Alex showed earlier to say that solving a problem is not like just to take the problem as a given and try to figure out the solution. And sometimes you really need to step back one step or maybe 5 steps to look over the whole picture and understanding whether the problem actually wasn't defined right. I think in this case, what I want to argue is that we do have that bigger question to ask. So how do I convince you we have a bigger question to ask? Let me just show you something you knew like 10 years ago, how IP works. Everyone knows. That's why I say my part of the talk is very lightweight. One packet goes from source address to destination address. So this is everything knows. Why do I mention it? Because when the security became a necessity, that's how we design the security. We mount that secure protection on top of this point-to-point communication. We use the TLS to secure the channels and thinking that we have the security. And I can tell you the story I had myself. I told this story to the NDN people, so you heard this already. Some years back, I was teaching an undergraduate course called CS118. Whoever out of UCLA heard about that course. I think that was in early June. That's our final exam time. The two disgruntled students that decided they got enough of me. They want to do something. So they impersonated me and posted it to the class. One, they cheated my assignment. But two, they attacked other students to say, how stupid you are, blah, blah, something like that. It was truly shocking. But my point is trying to say that, I look at the class discussion, and other students look at the class discussion from that secured channel. So what's wrong with the security? What's wrong with the security is that you don't really have the end-to-end security to really detect who produced that data, whether it's a true professor or somebody else. So that's why you have this fundamental security failure. Now you say, how about we just mount the end-to-end security on the IP? You cannot do that today. Why you cannot do that? There's mobile communications. We mentioned earlier that it changes addresses. Where is your TLS connected to? There's a recent work about Quick. They try to figure out how you can keep the communication secure even when you change addresses. But what about the DTN? That is, if there isn't a real-time connection between two ends, someone generates data but somehow gets disconnected, and another car carries the data to certain places. Now in this case, even Quick, I'm so sorry, that cannot work. So that's a problem. There's also other problems, like you talk to a bank. Of course, you want this highly secure, and you have TLS directly to your bank server. How do you know? Because you typed in, right, whatever your bank is, www.bankofamerica.com. And you know that your browser verified the certificate, so you are connecting to Bank of America. Is that true or not? And I tell you that many times it's not true, because I know that there are banks, I think there are many banks, that utilize the CDN services. For what purposes? Of course, they don't have a lot of content to distribute, so they don't need that kind of caching stuff. But they use the CDN as like a fence of defense for security purposes, because you cannot expect your bank people would be the security expert to be able to fence off all these malicious attacks, given how much value a bank has. So this shows you another example to say that you think you are secure end-to-end, you may not. So my question comes here is, how can we achieve end-to-end data security? End-to-end principle, I suppose every single one in this room heard about it. That's kind of a founding principle, one of the founding principles of the internet success. Now, when it comes to security, where is that end-to-end security? How come we do not have it? So I think here I should quote that statement to say that this is really the time we have to think about the problem definition, whether the end-to-end security can be achieved by securing the communication between two endpoints, and whether we should actually step back 10 steps and look at the whole picture to say that there's something more fundamental wrong, other than we not being smart enough. We need a new way to look at the networking. And this new way to look at the networking matches exactly the talk title that Van Jacobson gave that many years back. It's 12 years, I cannot believe time really passes, especially when you're getting old. I think even after 12 years, I would still encourage people to listen to that talk. That's why I give the URL there, because it hasn't lost its value. Maybe some details about NDN has changed since we didn't waste 8 years to study that. Then our understanding has deepened. But I think the first like 15 minutes, he talked something very, very fundamental. He gave an analogy to say that, you know that many years back, people thought the Earth was the center of the universe, right? And from there, they tried to predict the laws of how the planet all go moving around. But because the Earth wasn't the center of the universe, so therefore you try to write an equation to explain how the individual planet, come on, I'm not asking to change it, moving around the Earth, that's just difficult. And he said that once people give up the notation to say Earth is not the center of the universe and the sun actually is, then the equation became instantly way simpler, right? For at least the sun's, whatever the stars orbiting around the sun, if you take the sun as the center of the universe, then their equation becomes way simpler. So he used this to make a point to say that if you get a reference point wrong, the things are a lot harder. It doesn't mean that you cannot do things. You can. The Turing machine solved all the problems. So IP can solve all the problems. I would be the first one to agree with that. But just like a Turing machine, it's all about how long it takes. And for IP to solve all the problems we have today is about how complex the overall solution will become. So this new way of doing networking, well, we already heard this morning. I'm just giving you a more of the conceptual example to say this is IP and that's NDN. Get rid of the concept of nodes. Just think about name the data. You send request with a name and data will come back. And don't think about which node is going to reply. You do not know. Generally speaking, you do not know ahead of time. One question we heard the most of the time is about names. How dare you, NDN team, going to design the namespace and you force everyone to use? We do not, fortunately. Because you have to realize today, not today, anyone, anytime, what does the network do? Very unfortunately, you like it or not, the network is not the boss. Who is the boss? The applications. The network is no more than a servant to make applications happen. And we have to always to keep that in mind whenever we do research, do network research. So about the names, we, NDN, does not invent names. We merely say that applications, you already use names like all the URLs, then we just use that directly at the network layer to fetch the data that the application is already asking for without doing that the three levels of translation. Of course, the URLs is not fetching just one packet to this URL. Like this URL is man's talk. I don't know how long the talk is, but I know there's hundreds of packets, at least maybe 1,000. So therefore, you have to do fragmentation, chop the packet chop your content properly. I want to make the point is that every data packet has a unique name. Okay. So now you name data. That's the very first thing about name the data. That immediately comes the second point about security. Your naming data opens this new door for doing security in a new way. Why is a new way? Because here you see you have name, you have data, then you can sign it now. You can secure the data directly. Why can't you secure the data directly today? At the network layer. Because network layer uses different namespace. You give the address 1, 2, 3 for applications. One don't care, two don't understand. So you cannot secure the data with the address space. You can only do that in the transit moment, half second, or maybe 50 milliseconds, when the data goes from point A to point B in your TLS. In that moment, you think the data is secured. But as soon as the data get out of the TLS, that the security protection is over. And then your data usage will begin, and this out of security protection. And that's a problem. So NDN, by naming data, enables the data itself gets secured. This is independent from whether you go through TLS, which is good. Nobody said NDN doesn't use TLS. You know, you have TLS, you have another layer of protection. But the problem NDN wants to solve is that when your data get out of the TLS, you still have the protection. And you can achieve that by naming data directly. So you can just send it as soon as the data gets produced. That's my point. So with this will give us the end-to-end principle under the new context. In the new context is that there will be mobility, there will be DTN, there will be lots of middle boxes. But if you have the data producer send the data as soon as it's produced, and then you have the data consumer verify the signature, then you will have the end-to-end data authenticity, independent from how the data actually got shipped from the original producer eventually get onto your screen. This is the beauty, and this is the power. Yeah. Yes, sorry.
So my understanding of security is that authenticity, but also privacy. So if you have to tell the network what data you want, how do you get privacy?
So privacy, there's actually two questions. This is confidentiality, where I use a different term. There's the question of the confidentiality of the contents, and then there's the question of confidentiality of the name. So we actually handle these two things separately, right? I think that there's the confidentiality of the contents. For example, you bank with your Bank of America. This is not a secret. I believe I'm from LA. I mean, we all bank with Bank of America. But my bank balance, on the other hand, is a high secrecy, right? We want to do that. And then later in this tutorial, people are going to explain to you that how NDN automatically, without you have to worry about encryption, the system will handle the encryption and all this encryption, decryption keys automatically. Okay. About name confidentiality, it's a separate issue. I just want to point out that, so for one, we're working on that. For two is one level of interaction solve all the problems. You just need to have one level of translation to hide where you are. And I would add one more comment to say that do not think that IP provides you that name confidentiality. Okay, all you have is just one level of interaction, right? You get the address. You say you talk to the destination XYZ, but do a reverse lookup. You know exactly what XYZ translates to. That's one comment. The second comment is that, if a government wants to collect data, where do they do the collection? They don't have to go very far. They can sit on the Google and mount a gigantic TCP dump. They know exactly which source address comes to this site. On the other hand, as you have learned about the NDN, the packet carries no source address. So if the government wants to know, whoever wants to collect the data to say what you have done, there's no way you could just put a few probing points and then try to monitor anyone. Because unless you sit next to me, my router will record how many inches I transmitted. There's no other places you actually have that kind of very highly private information of where I have been doing the surfing or anything else. So NDN by design already has a high degree of the name confidentiality built in, making it very difficult to track, unless you put the probes at every home router. Well, maybe someone can do, especially in China, but I'm not going there. But at the higher level, yes, we can do just one level of interaction doing the translation. There's really computer science. There's no secret. There's a Turing machine that all the computation. There's a one level of interaction solve all the problem. But I do agree. There's another law under the sun. There's no free lunch. So therefore, we have end-to-end data authenticity. You pay the cost that you don't do today. What are those costs? Now, every data producer has to process the crypto certificate so that it verifies your key, so use your key to send your data. And well, I can put down here, so that the data consumers can actually verify your data. This is not anything you do today when you put up your laptop. There's no kind of a security bootstrapping to give you those digital credentials. That's something new you must do. And also that we talk about a lot today about IoTs, little tiny devices. They don't normally do the heavy duty crypto operations that great. So therefore, you have to have kind of different or good engineering to handle those kind of constraints. That's what I meant, that there's no free lunch on the sun, you get end-to-end data security for free. No, that is not. Now the question is that paying this cost, how much you gain? That's really our engineering big question. It's always a cost for anything you do. The question is whether you have like 10 times more gain, and then you're willing to pay the cost. During the lunch, I was chatting with somebody, talk about complexity. I was saying that I think everyone should know this, but maybe you're not thinking about this way. IP routers is n times more complex than the circuit switch, the circuit switches, right? But how come those simple circuit switch boxes are no longer with us? It's all about the trade-off, because now IP, I mean, the internet can do so many different things that the old circuit switch cannot do. And that's the right trade-off. And so it's here. That you make all these trade-offs, then you have fundamental gains. Because I'm not a security person, I always worry about when I talk security, I have no credential, nobody's gonna believe me. So therefore, I was quoting a big name in security to support my argument. This is Professor Alex Hoffman, is a well-known name in the security area. And back 2 years ago, when we had the NDN workshop, he went there to give this talk. This talk is still online. Whoever interested, you can just surf I think the NDN workshop at the NIST. Google will find that for you. The recording is there, the slides are there too. And he really talks about NDN a security perspective, how you look at this new architecture. And they started by saying that for security people, they do design, start with the requirement. Here is the threat model. And then you talk about how you overcome each threat that makes your solution work. But then he pointed out, we don't get to define future threats. But we do get to define the future algorithms and architectures. So, well, I didn't say it directly, but that's my interpretation. I think, so there is this new way to think about security. Instead of start from threat definitions, which we don't really know we get it right or not, even we get it right for today, but it's still right tomorrow. That's a big question mark. But what we do know is that we can design the architecture, the protocols, the mechanisms to give your system you develop certain properties. So, talk about looking for new challenges and new research topics. This is something new one should start thinking about. Think about the security solution from totally different direction. Instead of start from threat definition, you start thinking about your design, your mechanisms you want to design. Then you can argue that what kind of threat you have today, you don't have today. This new architecture can actually mitigate. That's one point. The next point is what I actually showed up on this slides. The basic is that this is a data-centric security mechanism that allowed us to convert the hard or harder security problems, like you secure the channel, secure the host, to a simpler problem, a relatively easier problem. Because in my earlier slides here, right? So assuming that crypto didn't fail us, if quantum computing becomes true, that's an entirely different story. But assume we are not there yet. If the crypto works, you want to achieve security, the problem becomes the proper use of crypto and then the management of the keys. This, Alex Haldeman argued, is a simpler problem, a better defined problem. Then you have to protecting, the whole network, the boxes, the channels, and the unknown entities that your data may have to pass through before they reach the final destinations. Again, like I said, I'm not a security person, that's why I'm trying to quote someone with more credential to support my point. When you want to do the crypto security, the number one question is the trust anchor establishment. You have a trust anchor, then from there, you can derive the certificate and you verify all the signatures you received, right? So the question is how to securely and easily establish trust anchors. Today, we establish trust anchor in a transparent way. So if it's transparent, you don't know it's the easiest way. The problem is how great it is. The trust anchors, that is the keys for all those certificates, people interpret CA as a certificate authority. I actually, because I'm not a security person, I want to verify it. I found out in the late 90s when this term showed up, it actually stands for certificate agent. Somehow, when the commercial CAs showed up, they want to call them authority, I guess, to turn into a certificate authority. In any case, this is where our trust anchor are. They are a bunch of commercial certificate authorities. That's how your secure HTTP connection get verified. The question is, who has said this bunch of companies are your trust anchors? I didn't say it. I'm pretty sure none of you guys said that. It's a third party decided for you on your back. So the later development, I think Alex mentioned earlier about this Let's Encrypt. This is actually the work by Alex Haldeman himself. They essentially to say that we automate the certificate issuance, and also we actually put all the certificate online and in public, so everyone knows who owns which certificate. This, I think, is a great step forward from today's commercial CAs. Today's commercial CAs have done lots of bad things. My point is that if you put certificate in the public, that's a very good result. But nevertheless, there are limitations there. That is, you have to own a website, so Let's Encrypt can verify your ownership of a namespace, they give you a certificate. What if you do the smart home? Where's your DNS name? How can you get a certificate assigned by the Let's Encrypt? There's also the question of, if you get certificate from Let's Encrypt, what does that mean, right? If you want to change certificate, how you do it if you don't change your names? There's the other question. So the trust anchor establishment, you have the tolerance, you have to deal with for errors. That's my understanding. Is that we say that each entity, big or small, can set up their own certificate trust anchors. The trust anchor, that is, this is the key for the trust that I start with. Then from there, I can derive other keys to sign data, send other keys, authorize other actions, etc. If you allow every party to set up their own trust anchors, the question is, under the sun, there'll be, 10 million more trust anchors. Now, how you authenticate data produced by each other. So there is a notion that how the trust anchors can establish relations among each other. I'm going to say just a little of that. But for that, let me talk about what we mean by local trust anchors. Local doesn't mean small, and local doesn't mean geographic locality, but rather it's kind of administrative local scope, like UCLA. UCLA pays us, employed us, so UCLA has the authority on anything under UCLA's control. So therefore, UCLA can be a trust anchor self-signed key, and through some offline ways, we'll install the trust anchor. With that, then all the other things UCLA authorized, I can verify, and I can follow the order. At your home, you don't want to use UCLA's key. So this actual picture is still from Alex in his presentation, that in my home, I want to be the authority of my home control, that I put the self-signed key in my phone. This is the trust anchor. I want all the smart devices in my home to obey this trust anchor that I established. Instead of, like, all my home devices controlled by the cloud in the sky, which I don't know who controls it. This is local trust anchor concept in the NDN. How you install the trust anchor locally? Well, depend on the different scenarios. UCLA will figure out their way how to disseminate trust anchor into their devices in a secure way. And at home, I think we need to develop solutions so that grandma living alone can still have this notion of smart home with the local trust anchor established. That needs lots of tools. I'm sorry. So talking about setting up the relations among different trust anchors, I again stole a picture. This actually was created by Van Jacobson back 8 years when an NSF Future Internet Architecture program just started. He gave this initial talk to sketch out this vision, to say that among trust anchors, they can establish trust relations to create this rich web of trustworthy information and also entities. This is the new way to develop trust relations. I can give you simple examples, like we are UCLA, we can have means to learn about UCSD, UC Riverside, UCI, UC Santa Cruz, and we can sign each other keys and give certain permissions, like what UCSB's key means and what I can do to UCLA-owned entities. This just gives you a notion. We're still very far away from having automated tools or support for this kind of inter-trust anchor relation establishment and other things. That's still far in our to-do list. What we have done up to this point is really things on this slide. That is, we can allow applications use name semantics because everything is named. But then you can use your name semantics to reason about your trust policies. When you receive a data, I receive a piece of data from Alex, then I understand Alex is my colleague. Then I can look at this data, what it means, and then okay. To say if you want to have access to my data, I will figure out whether I allow it or not. But at least I know this is Alex data, and I can understand what this key cannot do. Then we build some tools utilizing NDN naming conventions to do secure sign-in, certificate issuance, and others. I actually am so sorry. I don't know among the 4 lists how many you people are actually going to cover for the rest of the tutorial. But your time now. Okay, you can use your key. Yes.
So this the argument about the security envelope being the same, the transit and the at rest. Right? So
Secure envelope.
Security envelope, right? Being the same for the data at transit and data at rest.
I see. So I'm just repeating the question to the rest of the audience in case you haven't heard it clearly. So he was saying that in NDN, because you secure the data directly, so that whether the data is in transit or otherwise the data is at rest, that is in the storage, you are protected. This is a claim, yes.
This is the concept. Okay, so now I have a simple example like this. For example, Facebook decides to try ICM NDN, and maybe the feature is there's some user-generated content photo being uploaded to the Facebook server. Some photo being uploaded to the Facebook, and it has to be presented on the website. So this means that we have clear packets secured to the clients in transit to the backends, Facebook backends. And now, do we store the same packets like we put them in a database, and then every time we want to show it on Facebook, we have to reassemble these individual packets into the folder, and we have to decrypt every packet. So like, where's this boundary where we sort of break this security envelopment, have some actual bytes in storage, like in a real database. So, like, how does that look like? Because if you break this security envelope, then it's no better than what we have now with CK. It just intrinsic, right?
So let me say your question in my words. Basically, he's talking about security data versus the usage of those contents. When you use those contents, don't you have to remove all the security protection? Because you may reassemble content in certain different ways. Is that what you're...
Yeah, so
yeah.
The basic question is, do I write in a database every individual data packet, and then every time I have to...
So Ilya, you know a lot of things better than I do. NDN data is immutable. Data got produced, and that's it. This is the data. If you want to make use of that specific contents, you create new contents. How you protect the new contents, that will be determined by this new application. So you do not couple different applications together because they have different security policies and decisions and this and that. All you are seeing is that you have another application and you want to utilize the content produced in the previous security context. You have the permission to use the contents, and then you produce your own security policies to protect the new contents.